Hi, what's the next thing for us? Well, I just go on the canvas, go to home, back to week one. Week one is about textbook sections 2, 1, 2, 2, and 2, 3. So the next thing is textbook section 2, 1. So I forgot to put in the 1.4 there, sorry. Let's go to textbook section 2, 1, and let's see what we have here. I guess I should repeat myself. You don't need to buy this textbook. Everything you need you can get from the lecture notes if you're taking notes and from the canvas. But if you want to buy the textbook, yeah, please do so. Okay, 2 1. This is 2 1? Yes, this is 2 1. Right, now I'm going to tell you about scientific notation now. And I gotta say, uh, someone else is going to tell you about scientific notation too, and her name is Melissa Maribel. I've never met her, but I've seen her videos. I thought they were high quality, and I thought that those of you who are not accustomed to studying science might appreciate her a lot because her videos are very fancy, and I think they're meant for people for whom science is a rather new thing. Also, the captioning on the Melissa Maribel videos is already there, and it's wonderful. It's quite accurate. Now, let me go ahead with my explanation, and then please watch Melissa Maribel's explanation also. Right now, scientific notation. We use scientific notation in science for three reasons. The first reason is when the number is very large, it's hard to manage it. So this number is 5,100. That's not hard to manage. But what if you had a number like this? No, not like that. What if you had a number? Here, let me show you a nice large number. What if you had a number like this? We're going to use this number a lot in this class. This is 6.02 times 10 to the. This is 602. This is 6 with 23 numbers after it and then a dot. So this is 602 with, this is there are 23 numbers after this. So this is the 22nd, 21. So there are 21 numbers after, 21 zeros after this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 21 zeros after this 602. That would be a very hard number to write down and over again when you're doing a calculation. And you wouldn't even be able to put that in your calculator. And I don't care how expensive your calculator is. You could even be using a computer. You wouldn't be able to put that in there. There are too many zeros. So this is why we use scientific notation. The other reason is for very small numbers. Very often, we're going to see numbers like this in our class. What is this? There are there are three zeros between the dot and the first non-zero number. What does that even mean? This is a number that is so small it's hard to work with. Like while you're working, this happens all the time. While you're working with this problem, you're multiplying it by stuff, and then you're subtracting something from it or something like that, and then all of a sudden you write like only two zeros, and then for the next step you write only two zeros, and then the whole thing is wrong. Okay, so this is not a good thing. This is why we use scientific notation. When the number is too small, it's hard to work with. When a number is too large, it's hard to work with. And there's another reason why we use it. There's one reason that's not written here. It's significant figures. Significant digits are very important in chemistry, and that's because we make measurements with tools that are always imperfect. Why are the tools imperfect? The tools are imperfect because it's humans who are using them and humans who made them. There's a limit to what we could see in a tool, and there's a limit to the precision that we can put into the tool. But what was I saying? Oh yes, significant figures, significant digits or significant figures are very important in chemistry. I have a whole video about this later on, but just to give you the third reason why we use scientific notation, In scientific notation, these are only the significant digits. Yes, scientific notation only uses the significant digits. If there are other digits which are not significant, you will not see them in scientific notation. Here I have 3 digits. This is a 3 significant digit number. That's right. This other stuff, this isn't part of the measurement, but it's very important because it tells you the value of the measurement, the power of 10 that the measurement has. Okay? So, anyways, these are all significant. Significant. Sig for significant. All these digits are significant. This will, at any time, if you do not understand something, don't worry. Just feel the confusion, right? Accept it and move on. This is Chem 65. You are not going to understand 100% of chemistry in Chem 65. You need to, all you need to do is understand enough so you can do the work. Why is that? That's because as you do the work, understanding will come. That's how it happened to me, and that's how it's going to happen to you. I guarantee it. You might not get all the understanding that you want in this course, but you take Chem 101, Chem 102, Chem 211, Chem 212, it's gonna come. And when it comes, it's gonna feel really good. All right. So, this part of scientific notation is called the coefficient. This part is called the multiplier. Only in your textbook. I have never seen anyone else use those words in scientific notation. Usually, this number is called the mantissa, and this is the base, and this is the exponent. But no matter. Your textbook says coefficient and it says multiplier. I can work with that. So, what does this all mean? All right, so let me show you what this means exactly. So, this is what it means. 5.1 times 10 to the third. This number is the meat of of this quantity, of this measurement. This number tells you where to put the dot. It says move this dot over 3 spots. So you go 1, 2, 3, and then you fill in the rest with zeros. So that's your number, 5100. That's what that means. What about this number? 5.1 times 10 to the minus third. This means move this dot the other way, that way. 3 spots. Here we go. 1, 2, 3. Fill in with zeros and then put a dot. So this is 0.0051. It's the same as 0.0051. Some people like to put the 0 there. Some people don't like to put the 0 there. It doesn't matter, especially in this class, because whether you put the 0 there or not, Canvas is going to understand what you meant. So that's what scientific notation is. That's how to use it. Okay, I have a little something to say right here. Notice that I did not put a dot here. The dot goes back there, but you do not draw the dot there. You do not draw the dot there. That's where the dot goes, but you do not draw it. What about here? You do draw the dot there. That's where it goes, and that's where you draw the dot. Okay, why do you not draw the dot there? You do not draw the dot here because in chemistry, if you draw a dot here, it means something else. And you're going to see what it means in a future video about significant figures. So you just write 5100. So one more time, at the end of a number, if you need to, if you just translate it from scientific notation and you think you should put a dot there, you do not put a dot there. But at the beginning of the number, if you just translate it from scientific notation, you do put a dot there. Okay. I have some homework for you about this scientific notation, and here it is, scientific notation. And in this homework, I post a video. I post my video, but I post also Melissa Maribel's video. Her video is very good. And here is what I want you to do in the homework. I want you to do these problems, and I want you to notice that there are only 17 problems. However, I made, I think, around 31 problems. So you can do this homework assignment more than once. Every time you do this, the problems are going to change. The easy problems are going to change. The hard problems will remain the same, but the easy problems will change. And they will change a few times if you take the quiz a few times. I'm just going to keep the highest score that you have, so there's no worries when you take the quiz more than once. This is a homework quiz, not an exam quiz. Please note that the exam quizzes are not done at home. They are done in the presence of Dr. Valdez, your lab professor, and you only get one attempt with those, not two, not three, not unlimited, just one. But on a homework quiz, such as this one, you have unlimited attempts. I also have another piece of work for you to do um, associated with scientific notation, and that's on the Chem 101 app. Um, I hope you logged in and signed up for the Chem 101 app. Just in case you haven't, let me show you where to get that information. You got to go on the canvas and find week 1 and then log into the Chem 101 app. There's a PDF here, tells you everything you need to know. You can put this on your iPhone, your Android, or if you just want to use the computer, you can just use a website. I have a link there for you. Your classes, this one right here. Launch Chem 101 Web. When you open your app or open this website and you log in and you sign up for the course, you're going to find that there is a scientific notation and significant digits homework. Yeah. And you're going to do this homework. Yes, you are. And I guess I can't show you what it looks like, but I think you'll see. It looks very similar. I mean, the problems are very similar to what you'll see in this in oops, what you'll see in the homework that I just showed you from Canvas. You know, the one with the Melissa Maribel video on it. All right, now before you do that homework, however, before you do that homework, please do the significant figures homework. All right, here, let me put this in different. Oh, it is already in order. So I want you to do the significant figures homework first, and then the scientific notation homework. And that's because scientific notation, the third reason why we do scientific notation is because of significant figures. And so it's best if you know significant figures first, and then you do scientific notation. Thank you. Bye.